Hey guys, it's Mr. Post, and on today's video we'll be learning how to draw Lewis dot structures for ionic compounds and determining the formula of an ionic compound using the Lewis dot structures. Okay, let's start off. In order to do a Lewis dot structure, we need to know how many valence electrons an element has. And this table here is going to illustrate that. At the top here, these are my group numbers. Okay, so these are my groups. Well, my pen's going a little crazy there. Those are my groups, and they illustrate the number of valence electrons. So every element in this group has one valence electron, every element in this group has two, etc. 6 valence electrons, 7, and 8. The Lewis dot structure drawn for an element is simply a way for scientists to express important information about an atom's electron cloud using a simple picture. Okay? And it's only going to show us the valence electrons. So how many valence electrons does chlorine have? Well, if I go back one slide, all right, there's chlorine right here. Okay, go up to the very top of the group, and I'll see it's in group 7, indicating 7 valence electrons. I'm going to draw my Lewis dot structure showing those valence electrons. These dots here represent the valence electrons. So any Lewis dot structure is simply showing the outer edge of my electron cloud, the valence electrons. There's examples here. Sodium is located in group number 1, therefore it has 1 valence electron and 1 dot representing its outer shell electron. Magnesium is located in group 2, and therefore you see 2 outer shell electrons, and chlorine is in group number 7, and it has 7 outer shell electrons. This is an illustration of the first 20 elements of the periodic table and their electrons. And you'll notice that all the elements in group number 1 have 1 dot or 1 valence electron. All elements in group 2 have 2, 3, 4, 5, 6, 7, and in this case 8. There's an exception to the octet rule right here. Helium only has 2 in its outer shell. That's all right. So if we check this out, nitrogen and all the elements in nitrogen's group all have the same exact electron cloud on the valence shell, 5 outer shell electrons. And we tend to draw these electrons in 4 places. I call it 12 o'clock, 3 o'clock, 6 o'clock, and 9 o'clock. Now in order to do ionic compounds using a Lewis dot structure, we first need to know how to do it using the elements alone. Now we're going to start combining them together to form Lewis dot structures for ionic compounds. Once again, this is simply a simple way for scientists to express important information about the formation of my ionic compound. Okay? And the key here is showing the valence electrons only. Simple expression. This is the electron cloud drawn simply for sodium. And you'll see that it has 2 electrons on its inner core, 8, and finally it has 1 electron in its outer energy level, and that electron is going to be represented by 1 dot. Chlorine has 7 electrons in its outer energy level, and we're going to represent those electrons by the 7 electrons you see here by 7 dots. Now, in order to complete my Lewis dot structure, what I really need to do is show how my electron is transferred over to chlorine in that fashion. Let's draw the Lewis dot structure for sodium chloride. It starts off by drawing sodium as an element, using its 1 electron and drawing that at either 12 o'clock, 3 o'clock, 6 o'clock, or 9 o'clock. I'm just going to choose right here. And then drawing chlorine. I'm going to shade this guy in so we know what we're dealing with here. Chlorine is in group 7, and it has 7 outer shell electrons. 1, 2, 3, 4, 5, 6, 7. And so once again, if I'm doing sodium chloride without the help from the previous slide, I'm showing that I'm going to transfer it right over here so that now this has 8 in its outer shell. Atoms will either gain or lose electrons in order to have 8 in their outer shell. So sodium has lost its outer shell electron. That is exactly what it wants. Sodium gained 1. I have my octet, and I fell back to my interior or core octet in this case. The formula unit is Na1Cl1, or simply NaCl. What I'd like you to do is try to draw the Lewis dot structure for sodium oxide. Take a shot at it, determine the formula unit from the Lewis dot structure, and see if yours matches mine. Just press pause on the screen and give it a shot. Okay, so as we saw from the last slide, sodium has 1 electron in its outer shell because it's located in a group 1. Oxygen has 8. I'm sorry, oxygen has 6 rather. 1, 3, 4, 5, 6. Sodium is going to transfer one of its electrons over here to give oxygen 7. But oxygen still needs another electron down here. When that happens, you need to make another sodium with 1 electron to give away, and it will plug its electron over here. So sodium has lost all of its outer shell electrons on that atom and on this atom too. Oxygen has gained 2, so it has 8. So therefore, I'm done. I've gotten rid of all of sodium's electrons. I've gained all that I needed to for oxygen. My formula is going to be Na. I'm going to count them up. I have 2. 1, 2, and I have 1 oxygen. Na2O. Okay, this one is a little more challenging. Let's give it a shot. Aluminum oxide, give me the Lewis dot structure, tell me what kind of formula unit that produces. Press pause, give it a shot. Aluminum has 3 outer shell electrons, it's in group 3. Oxygen, as we've already seen, has 6. 1, 2, 3, 4, 5, and 6. And I'm going to transfer aluminum's electrons over here. One's going to go there, and the other one's going right there. I still have 1 more to get rid of down here. Now oxygen has the 2, the 4, now it has 5, 6, 7, 8. It is full, alright? I'm done with that oxygen. But I still need to get rid of my other aluminum. Okay? My other aluminum's electron still needs to go somewhere, so I'm going to make another oxygen. Let's draw it. 1, 2, 3, 4, 5, 6. I'm going to lose aluminum's last electron right to there. This aluminum is done. The electron cloud on the valence shell has been emptied. But I do have an issue. I still have another oxygen that needs 1 more electron. When that happens, make another aluminum with 1, 2, 3 outer shell electrons. And this is going to be plugged in right there. Awesome. This oxygen now has gained 2. It has 8 in its outer shell. But I still have 2 more to get rid of. And I'm going to do that by making another oxygen. And here we go. Aluminum is going to transfer to electron right there, and the last electron will go there. It's a crazy looking picture, but what I want you to see is that aluminum has lost its outer shell electrons perfectly. Oxygen has gained all of those outer shell electrons. Count up the number of aluminums. I have aluminum over here. That means I have 1 aluminum over there, and the other aluminum right there. So it gives me Al2, and also gives me 1, 2, 3 oxygens. And the formula unit is Al2O3. I got this using my Lewis dot structure. The last Lewis dot structure we'll be constructing today is for calcium sulfide. You know the drill. Press pause, give it a shot. Calcium is in group 2. That means it has 2 outer shell electrons. Sulfur is in group 6. And what I'm going to have here is a simple structure. Gives its electron right over there, and the electron is taken and brought over there as well. So calcium has lost all of its outer shell electrons. Awesome. Sulfur gained 2 more, and now it has 8 in its outer shell. Fantastic. Both are satisfied. I end up with Ca1, S1. And guys, that concludes our Lewis dot structure lesson. Hope it was helpful. Enjoy.